There's a pretty solid rule in nature that almost everyone accepts without question. Land predators hunt on land, ocean predators hunt in the ocean. But here's a fact that should genuinely unsettle you. There was a period in Earth's history, stretching across roughly 100 million years, where some of the most lethal apex predators ever to exist absolutely refused to follow that rule. I'm not talking about creatures that evolved halfway into fish. I'm talking about predators built for land, that dominated on land, that had perfected hunting on dry ground for millions of years, and then looked at the ocean and said, "We're taking this too." These weren't anomalies. They weren't desperate experiments. They were successful, dominant, terrifying predators that conquered two environments simultaneously, and the ocean absolutely paid the price. But to understand how this was even possible, you need to understand one critical thing. The oceans were vulnerable. The oceans had just recovered from the worst extinction event in Earth's history, the Great Dying. 251 million years ago, 83% of all marine families went extinct. Everything that had dominated the water for millions of years, suddenly gone. When the oceans recovered, they rebuilt with limited predator diversity. Here's the critical detail. These recovering predators had all evolved their strategies in response to other aquatic predators. They knew how to compete with sharks, with other crocodilians, with ancient fish. But they had no evolutionary answer for something that could walk on land, breathe air, and then casually wade into the water and apply land-based hunting strategies to an aquatic environment. That was a competitive scenario they had never encountered in their entire evolutionary history. This vulnerability would persist for roughly 100 million years. The Cretaceous, the Eocene, parts of the Cenozoic. During this entire window, the oceans were populated by creatures that had no evolutionary framework for defending against terrestrial hunting strategies applied underwater. Which means if a land animal figured out how to hunt in water, it had basically found a cheat code, a vulnerability that nothing had evolved to counter. Let's start with one of the weirdest success stories in mammalian evolution, the whale. About 50 million years ago in Pakistan, there was a creature called Ambulocetus, walking whale. Imagine a four-legged mammal, the head of a crocodile, the body length of a sea lion at 3 to 3.5 meters or 10 to 11.5 feet. It still had four legs with actual toes. No flippers yet. This thing was committed to being on land while also hunting in water. Talk about refusing to pick a lane. Its head made up almost 25% of its total body length, packed with large, recurved teeth designed for gripping wet, slippery prey. Those eyes weren't positioned forward like typical predators. They were on the sides, giving it semi-aquatic vision while mostly submerged. Its nostrils were positioned high, allowing it to breathe while nearly completely underwater, just like a crocodile. Fossil evidence shows Ambulocetus hunted in shallow rivers and estuaries. It would wade in using powerful hind limbs, approach prey that had zero evolutionary experience with a four-legged mammal hunting in their territory, and drag them back to shore. The fish it hunted had defenses against sharks, against other fish. But a mammal that could breathe air, walk on land, and hunt in water, that was a defensive scenario they literally hadn't evolved against. Which means they were basically defenseless. Ouch. So Ambulocetus was the first land animal to realize it could be an apex predator in the ocean. And it worked so well that its descendants eventually decided land is overrated and committed to water entirely. Those descendants? Modern whales. Pretty wild. While Ambulocetus was experimenting in Pakistan, on a completely different continent, something even more terrifying was happening. Theropod dinosaurs also decided to invade aquatic environments. And not just any theropod, the absolute apex of apex predators. Its name was Spinosaurus. At 15 to 17 meters or 49 to 56 feet long, it was bigger than a T-Rex. But here's what's actually crazier. Spinosaurus spent significant portions of its life actively hunting in water. Unlike Ambulocetus, which was still figuring it out, Spinosaurus was basically born for it. This was during the Cretaceous period, roughly 100 million years ago. At that time, Earth was going through the Cretaceous thermal maximum, extreme global warming unlike anything in the modern world. The average temperature was around 12 degrees Celsius higher than today. Because of that warmth, sea levels rose dramatically, and that rising water created vast, shallow inland seas that covered North America, Europe, and parts of Africa. These weren't open oceans. They were warm, tropical, shallow seas filled with fish, sawfish, primitive cephalopods, and sea turtles. Spinosaurus had evolved specific adaptations for hunting in these waters. Its tail was flattened vertically like a crocodile's. Paleontologists initially thought it was purely ornamental, but biomechanical analysis proved that wrong. When Spinosaurus moved that tail side to side, it was generating serious propulsion through water with crocodile-level efficiency, which means it wasn't just visiting the water, it was dominating it. Its hind limbs were relatively short for a theropod, which sounds bad until you realize short, powerful legs are exactly what you need for generating force through water. Its nostrils were positioned high and toward the back, allowing it to breathe while almost completely submerged. Basically, it was a dinosaur that studied how crocodiles hunt and said, "Yeah, I can do that better." Then there were the teeth. Not serrated like other theropods, conical, slightly curved, designed specifically for gripping slippery prey, like a crocodile's teeth. 5 to 7 inches or 12 to 18 centimeters in length. These weren't for tearing. They were for holding, which is somehow worse. And the claws. Forelimb claws reaching around 16 inches or 40 centimeters long. These weren't for slashing. These were precision gripping tools. One study analyzing wear patterns on fossilized Spinosaurus claws found evidence of repeated contact with aquatic prey. Shells, scales, fish remains. Talk about leaving a trail of evidence. A Bite Force study found Spinosaurus had around 9,000 to 12,000 newtons, less than a T-Rex. But that doesn't matter when your entire strategy doesn't rely on crushing. It relies on pinning, holding, gripping. In other words, Spinosaurus looked at the ocean's apex predators and said, "I'll take your turf and keep mine." And it worked. For 46 million years, from roughly 112 million years ago, all the way to 66 million years ago, Spinosaurus maintained apex predator status in both environments. One study looked at fossils from the Kem Formation in Morocco, a Cretaceous river system. What they found was striking. Spinosaurus wasn't just successful. It was so dominant that it completely altered the ecosystem. It changed which predators ruled. It changed which prey survived. Fish species that had thrived for millions of years began declining, which means every fish in Cretaceous rivers lived in constant terror. Now here's where things get genuinely disturbing. Because once mammals committed to the ocean, they didn't just become peaceful filter feeders. They became nightmare fuel. Meet Basilosaurus. The name means king lizard because when it was first discovered in the 1830s, paleontologists thought they'd found a marine reptile. They were wrong. This was a whale, but not like any whale alive today. Talk about a plot twist. By 37 million years ago, during the Eocene, the world had transformed completely. Dinosaurs had been gone for millions of years. Mammals dominated every terrestrial ecosystem. But in the oceans, something was about to happen. The Eocene climate was warmer and wetter than today. More tropical. Oceans were roughly 13 degrees Celsius warmer than present day. Food was abundant. But prey populations were vulnerable. Aquatic predator diversity was still recovering from ancient extinctions. The ecosystem hadn't fully solidified yet. At 15 to 18 meters, or 50 to 60 feet long, Basilosaurus had an elongated serpentine body. Its skull alone was over 1.5 meters or 5 feet long. And unlike modern whales, this thing had teeth that would make a great white shark jealous. Large, serrated, triangular teeth designed for one thing: tearing apart large prey, which is absolutely not what you expect from a whale. Stomach contents and bite marks on other fossils tell us exactly what Basilosaurus hunted. Other whales. Specifically, it targeted Dorudon, a smaller whale species about the size of a modern dolphin. Fossil evidence shows Basilosaurus didn't just kill them. It systematically dismembered them, crushing skulls and severing spines with surgical precision, which is horrifying. One study found juvenile Dorudon remains with bite marks that match Basilosaurus teeth exactly. These weren't scavenged carcasses. These were active hunts. A land animal that had fully committed to the ocean and then became the ocean's apex predator by hunting its own relatives. Talk about betrayal on an evolutionary scale. And here's the thing that should genuinely unsettle you. Basilosaurus hunted in packs. Fossil sites from the Eocene often show multiple individuals together, suggesting coordinated hunting behavior. Imagine being a smaller whale 37 million years ago, and a pod of 50-foot serpent whales with shark teeth starts circling you. There's no escape. You can't outrun something that big in water. You can't hide. You're just prey, which is the worst position to be in. The ocean had never seen anything like this, and it worked for over 10 million years. Now let's jump forward to the Cenozoic. Terror birds, the Forus racids, are already notorious for being terrifying on land. But they also hunted in water, regularly, successfully. Which means, if you were a fish back then, you had threats from literally every direction. They ranged wildly in size. Early members were maybe 1 meter or 3 feet tall. But by the Miocene, You had species like Kelenkin standing nearly 3.5 meters or 11.5 feet tall, taller than any human, with a skull taking up 1/3 of total body height. Just picture that. A bird, taller than you, with a head the size of a car. Not great? On land, they were cursorial predators, powerful hind limbs, minimal wings, talons that could puncture and slice, speed estimates, 40 to 50 kilometers per hour, or 25 to 31 miles per hour. Basically avian freight trains. But paleontologists found extensive evidence that terror birds regularly waded into shallow water and coastal areas to hunt aquatic prey. Their long, powerful legs gave them something no dedicated aquatic predator had: the ability to chase prey through water while maintaining vertical orientation and reach. They could stand in water, look down, strike, which means fish couldn't even use dive deeper as an escape strategy because the terror bird could just walk in deeper. Their beaks were sickle-shaped, curved with sharp hooking edges. Biomechanical analysis suggests they hunted with a strike-and-drop method. Rapid strike, toss the prey back, swallow whole. Multiple specimens had aquatic fish as gut contents. One specimen had juvenile caiman remains mixed with river fish. These weren't accidents. These were active hunting strategies, which means this bird literally specialized in hunting things that had armor. They did this for millions of years, from 62 million years ago until about 2,500 years ago. That's not an experiment. That's a proven, successful, refined hunting strategy tested and perfected over geological timescales, which means if you were alive 10 million years ago in South America, you basically had no safe water. Ouch. And it wasn't just reptiles and birds. Mammals were also getting in on the action. The early pinnipeds, ancestors of modern seals and sea lions, were experimenting with aquatic hunting starting around 33 million years ago, which means by the Cenozoic, literally every animal group was finding ways to dominate the water. Meet Pugila. It lived around 33 million years ago and represents the exact moment when a land-based mammal said, "Okay, water hunting is happening now." Still very much a land animal at one point, 1 meters or 3.6 feet long, with fully functional legs and a body plan like a small otter. It could walk normally on land. It could run. It could climb. But it could also dive and hunt fish in near-shore environments. Talk about versatility. Fossil stomach contents from Pugila specimens show fish bones, crustacean remains, and other aquatic prey. One study comparing bone density found that Pugila had already begun increasing skeletal density to help with underwater hunting, an adaptation that takes millions of years to evolve. Yet Pugila was doing it while still maintaining fully competent land-walking abilities, which means it was actively mid-transition, caught between two worlds, and winning in both. But then came Potamotherium around 25 to 20 million years ago, Pugila's more specialized cousin. At 0.6 to 1 meter, or 2 to 3.3 feet long, it was smaller but far more specialized for aquatic hunting. Its body had streamlined. Its limbs were becoming more flipper-like, still capable of land movement but clearly optimized for water. Its tail had elongated and flattened as a rudder, which means evolution was saying, "Okay, this aquatic hunting thing is working. Let's lean into it." Potamotherium represents the moment when a land predator's aquatic hunting strategy had become so successful that the next logical step was obvious: fully commit. Over the next million years, pinniped evolution would accelerate toward full aquatic specialization. Yet, for a brief window, Potamotherium hunted like neither a land animal nor a true sea creature. It hunted like something perfectly in between, and it dominated in that space. So here's the question. How did land animals just invade aquatic environments and become apex predators? And more importantly, why did they all seem to figure this out at the same time? Talk about unfortunate timing for the ocean. The answer comes down to three primary factors. First, prey had no defense against them. When Ambulocetus started hunting in rivers, the fish had evolved under pressure from sharks, large fish, semi-aquatic crocodilians. But none of those predators hunted like Ambulocetus did. A mammal that could breathe air, walk on land, and swim efficiently, that was a predatory approach 50 million years of evolution hadn't prepared anyone for. The prey was basically helpless. Same with Spinosaurus. Cretaceous fish had never dealt with a 17-meter theropod hunting like a crocodile. Terror birds applying land-based hunting speed to shallow water. Fish and caimans had no response strategy. Basilosaurus hunting other whales in packs. Nothing in the ocean had faced coordinated mammalian pack hunting before. Second, ecological opportunity. These weren't invasions into saturated ecosystems. The Eocene rivers weren't crowded with massive aquatic apex predators. The Cretaceous wetlands had abundant prey and limited top-tier competition. The Cenozoic coasts had ecological niches simply not being filled by specialists. These animals didn't have to be better than established competitors, just different enough that prey hadn't adapted against their specific hunting style, which is basically nature's definition of unfair. Third, they didn't need to evolve their tools from scratch. Ambulocetus didn't invent ambush hunting. Land mammals perfected that. Spinosaurus didn't invent gripping prey teeth. Crocodilians had done that. Terror birds didn't invent speed or powerful strikes. Cursorial predators refined those tools. Basilosaurus didn't invent pack hunting. Land mammals had been doing it for millions of years, which means all these creatures were just applying existing weapons to a new arena. But here's the critical ecological principle underneath all of this. The ocean was vulnerable specifically because it was recovering. Limited predator diversity meant limited predator-prey coevolution. Prey hadn't evolved comprehensive defenses. Aquatic predators hadn't evolved competitive strategies for dealing with generalists. As millions of years passed, that vulnerability closed. Aquatic predators diversified dramatically. Great whites emerged. Orcas evolved. Specialized deep-sea hunters developed. Anglerfish. Gulper eels. Every niche got a specialist. Each one refined its hunting strategy through millions of years of competition with other aquatic predators. They evolved defenses against each other. They specialized in specific prey. By the modern day, aquatic ecosystems are completely saturated. There's no empty niche for a generalist to exploit. Every hunting strategy has been refined through millions of years of direct aquatic competition. Every possible prey size, prey type, and prey behavior has an evolved predator response, which means the age of land animals as apex ocean predators is fundamentally over. But like everything in nature, this era didn't last forever. Spinosaurus? Gone. 66 million years ago. Asteroid impact. Doesn't matter that it conquered 2 environments. One big rock from space ended that experiment. Evolutionary success doesn't mean extinction-proof. Ambulocetus and its relatives didn't go extinct. They committed. Over millions of years, descendants like Basilosaurus became increasingly specialized for aquatic life. Eventually, legs became flippers. Nostrils shifted into blowholes. Bodies streamlined. By the time you get to modern whales, they're fully aquatic specialists. They can't walk on land, which means they essentially abandoned the land. Ouch. Terror birds hung on from the Paleocene until about 2,500 years ago. Then humans showed up in South America, hunted them, destroyed habitats. End of millions of years of successful aquatic hunting, which is the worst timing possible. Dominate for 60 million years and then get wiped out in a few thousand by a species that hadn't even invented agriculture yet. So why did this strategy stop working? The answer is competition and specialization. As oceans and rivers filled with dedicated aquatic predators over millions of years, selective pressure changed. It became more efficient to be a full-time aquatic specialist than to maintain toolkits for thriving in both environments. Why keep 4 legs when you could turn them into flippers? Why maintain land mammal respiratory systems when you could evolve cetacean lung capacity? Natural selection doesn't care about versatility. It cares about efficiency in your current environment, which means natural selection basically said, pick a lane or lose to someone who does. So here's the thing about that boundary between land and sea, the one that feels so absolute, so natural. Land predators hunt on land. Ocean predators hunt in the ocean. That's the rule now. Except it's not set in stone. It never was. For a brief moment in geological time, millions of years is literally the blink of an eye on Earth's timescale, that boundary didn't exist. Land animals absolutely dominated in water. Ambulocetus was better at hunting certain prey than anything aquatic. Spinosaurus was arguably the most powerful predator in its environment, period. Basilosaurus turned the ocean into its personal hunting ground. Terror birds went millions of years as successful aquatic hunters. The pinnipeds proved the same principle worked across another mammalian lineage, which means the ocean basically belonged to creatures that weren't even designed for it. But that time is gone. We live in the era where those lines are firmly drawn. Whales are fully aquatic. Spinosaurus is extinct. Terror birds are extinct. Which means we're actually living in the rarer time period, the one where ocean and land stay in separate lanes. And honestly, if a land animal like Spinosaurus still existed today, if it still hunted regularly in the ocean, every other apex predator on the planet would just be secondary. Every great white, every saltwater croc, every orca. The modern marine food web would collapse under a generalist that hadn't needed to specialize for 100 million years. Every ecosystem has no defenses prepared. Every prey species would have zero evolutionary experience with that hunting style. The ocean would reset to vulnerability in an instant, which is both comforting and terrifying at the same time. Be grateful evolution moved on from that experiment. Thanks for watching, and until next time.